Then for the trickier part for sound itself is actually what we call an echo. So an echo is a reflected sound. So the thing is, whenever we are dealing with echo itself, we do not use V equal F lambda. We will just use speed is distance over time. Okay? So in this case, you want to always double check the terms. Because if you want to find the speed of an echo, look at what the question gives you. Is it the change in time? If they give you change in time, you have to use change in distance. If they give you total time, we have to use total distance. So you always have to correspond to whatever that you have. Now, if the question don't give you a diagram, just sketch it out. So for example, if I'm clapping my hands over here, the sound will travel back and forth. So can you see that the distance is actually 2 times the distance? So if, for example, I hear my clap 1 second after I clap, basically means the time taken is 1 second, right? Then the total distance will be 2d. So if the speed is given like 330 meters per second, if I want to find distance d, first thing I'll just take distance over time, right? By right, it's 2 times the distance over 1 second. This is equals to 330. So if this is the case, my distance is actually just 165. If I'm not wrong, let me just double check. 330 divided by 2, 165, yes. So I'm actually 165 meters away from the wall itself. So this part, right, even though I write velocity is distance over time, it's actually total distance over total time. So you need to be very, very careful itself. This one, you actually need to be careful which values you use accordingly, okay? So just be careful whenever you have an echo question, sketch it out, especially if they don't give you the diagram, sketch it out. Even if they give you the diagram, draw out how the sound would travel. Then you can actually be able to identify which is which. Okay? The next, ultrasound. Now, ultrasound, basically the word ultra means beyond. Okay, ultra means beyond. So ultrasound just means beyond human hearing. So humans can only hear 20 hertz to 20,000 hertz, which means your ultrasound is greater than 20,000 hertz. Okay, and what do we use your ultrasound for? I'm pretty sure some of you have watched TV shows before where they use for prenatal scanning to check pregnant ladies and for your quality control, because number one, sometimes this is to check for hidden cracks that are not visible. Okay, because sometimes with the human eye or maybe externally looks like there's no problem, but inside maybe the concrete pillars, there's cracks in between, a lot of air bubbles and stuff like that. So using ultrasound, you can actually use this to double check without causing a lot of noise, because if you were to use normal sound, it will be very, very noisy, right? So even construction already very noisy, you want to make it even more noisier. Nobody wants that, right? And animals also use echolocation. So bats, your dolphins, they all use echolocation. They don't actually use their eyesight to help them navigate dark environments itself. Now, if you notice, the girl is standing 150 meters from the wall, from the building itself, and she fires a shot. And it hears 2 bangs 1 second apart. So in this case, the change in time is 1 second. So if you want to find change in time, if you want to find the speed, I will have to write speed is equals to change in distance over change in time. So the first thing we need to ask ourselves is, what's the distance traveled by the first bang? First bang, just travel like this. The second bang will travel like this. A total of these 3, right? So if you want to find the change in distance, I'll take the bigger green one minus the smaller one. So 150 plus 150 plus 350 minus 350. So you end up with 300 meters. So change in distance is 300 meters. Distance, time taken is 1 second. So my speed of sound will just be 300 meters per second itself. So you see, if they give us change in time, I have to find change in distance. If they give me total time, I'll have to find total distance. Okay, so you have to be very, very careful which one that you're using and which one we use. So you see, we don't use V equals to F lambda at all. We will use the speed formula to solve. Now, what is an echo? You can just write there, an echo is a reflected sound wave. That's it. What's using the ultrasound machine can detect cracks that are not visible on the outside. Because they told you over visual inspection, it means you just use eye power, CC, look what happened, right? So using this ultrasound machine can allow you to detect any kind of cracks that are not visible on the outside, and therefore you can actually prevent any kind of damage. Because especially if you're building infrastructure, buildings and all that, if you have all these cracks, what happens is that the building might actually collapse if you never do it properly itself. So having this ultrasound machine will actually allow you to detect for any kind of hidden dangers that is not visible to the outside eye.